Hello there, welcome to Science Class. Science Class is a YouTube channel that is dedicated to tutorials on mathematics, physics, and chemistry, and we share useful information and tips about job employment, scholarship opportunities, and other materials that benefit young people. In today's topic, we shall be diving into introduction of physics. Introduction to physics. Prior to this time, on this channel we have been discussing mathematics from the basics, and we are gradually advancing into the more advanced level. But in this lesson, we shall be discussing introduction to physics. It is a branch of science concerned with nature and properties of matter and energy. Is a branch of science. Physics is actually a branch of science that concerns itself with nature and property of matter. Matter is anything that has weight and occupies space. All matter, anything that has weight and occupies space, even air that we breathe in is a matter. Energy, in the other sense, is the ability to do work. Anything that has the ability to do work is energy. Lifting, lightning, burning, they are all energy. Yes, so physics can also be defined as the physical plane of matter, motion, force, and energy. This is looking like a little bit dicey, but this simply means the physical dimension of matter, of motion, not only matter now, but of motion, of force, and energy. If some of these terms look very, very new to you, just keep watching this science class, and gradually we shall be discussing some of these terminologies in detail later. The root word physics is from a Greek word meaning physics, which means nature. And matter, as I said, is anything that has weight and occupies space. Physics concerns itself with mechanics, heat, light, and other radiation, sound, electricity, magnetism, and other structure of atom. Like I said initially, some of these terminologies will look so new to us, but let us just continue to watch the science class. We are going to be breaking down all these terminologies into bits later on, such as matter, such as atom, such as magnetism, and all that. Yes, we have different branches of physics. There are a lot of ways people classify the branches of physics, but in today's tutorial, I'm just going to be classifying physics into 7 branches. 7 branches. Yes, 7 branches. The first one is optics, second one is electromagnetism, third one is relativity, fourth thermodynamic, fifth acoustics, 6 quantum physics, 7 mechanics. Let me just quickly run through some of these things that I've said. When you hear of optics just means light. Electromagnetism means generating magnet from electricity. Relativity means the principle of comparing 2 forms of energy, 2 matter, 2 things in the same space. Comparing them together, it might be in terms of their motion, it might be in terms of their friction. We're going to be discussing all this later on. Thermodynamics. Whenever you hear the word thermo in science or physics, it means heat, and dynamics means movement. So thermodynamics simply means heat movement, and it is one of the classification of physics. Thermodynamics. Acoustics is another one. Acoustics has to do with sound. You see, scientists sometimes, whenever they want to get the depth of ocean, they send sound into the depth of the ocean. And when the sound hits the ocean bed, there will be a vibration that comes back to the surface of the water. And with sound, scientists have been able to know the depth of seas. They have been able to know the distance of a point to a cliff and all that. So acoustics has to do with sound management. You listen to music, good music from wonderful artists. They are product of acoustics, that is from physics, from noise control in studios and all that. Then we have quantum physics. Quantum physics has to do with physics of molecules, small molecules, small tiny bits, radiation, half-lives, and some other forms of energy that we're going to be discussing later. Then we have mechanics. Mechanics of material has to do with something like force, something like friction, something like pull, push, force acting upward, force acting downward. And so I know this could be a little bit boring, but I just want to pick interest in what I'm saying. I want you to pick interest and just note some of these new words down. You could get your dictionary and just check on some of these words in the dictionary. What is science? Science, just like I told you, physics is an aspect of science, is a branch of science. But what is science? What is science? Science is the pursuit and application of knowledge. Whenever you pursue and apply knowledge, if you pursue knowledge and apply it, you are practicing science. So, science is the pursuit and application of knowledge, understanding natural and social world, following a systematic methodology based on evidence. You understand what I'm trying to say? Scientists, they don't just assume. When they pursue knowledge, they try to apply the knowledge to the nature, to their social world, they use the knowledge to what we can see, what we do every day: build houses, make cars, fly aeroplanes, build vessels that sail in the ocean, to make telephones that we used to call, and so many inventions that you see. So whenever you apply the knowledge that you've gained, you are practicing science. There is a systematic method or methodology by which scientists carry out all these methods, and that system is called scientific method. That system is what is known as scientific method. And what is scientific method? Scientific method has 5 steps. The first step is observation. Scientists, they observe. Whatever they see, they try to observe. Why do we have to look up to see the sky? Why is it that when a stone is thrown up, it falls back down? Why is it that water is colorless? This is the beginning of science. This is the beginning of scientific method. This is the beginning of pursuit of knowledge. You ask questions by observation. So a scientist or a physicist must be able to ask questions because he must have observed one thing or the other. Then after observation, the next step is data collection. When they have carried out observation, they begin to take data, they begin to take measurement, scientists begin to get their facts from what they are saying, begin to do their own research and collect data from that research, from that what they have observed. And hypothesis means guesses. They begin to bring out guesses that, okay, from what we have observed, it is likely this is supposed to be this. It is likely that because the sky is above our head, that is why we need to look up whenever we want to look at the sky. Then the third method is, yes, hypothesis. Hypothesis, I've already said that after data collection is hypothesis, which means they make some guesses. Then after making guesses, they begin to analyze those guesses. What they have guessed, they just thought, oh, this could have been why this thing behaves this way, or we have to do these things this way to achieve that. Then they begin to analyze. They begin to put their heads together to analyze and try to come out with a solution or a conclusion. And the last step in the method is conclusion. Method number 5 is conclusion. After they must have analyzed everything they have observed, everything the data they have collected, they bring out a conclusion. And when they bring out the conclusion, that conclusion is subject to other people's review, other people's confirmation. And when that has been done by several people and they get a consistent result, a consistent conclusion of what has been done, then that turns to a theory. Example of what I'm trying to say here is gravity. The value of the gravitational force anywhere on Earth ranges between 9.81 meters per second to 10 meters per second, because it has been tried in different locations in the world, and the value is within 9.81 meters per second and 10 meters per second. So it is now a theory or a law that gravitational force is that gravitational pull has an acceleration of 10 meters per second square. 10 meters per second square or 9.8 meters per second square, whichever one that applies. But on the average, 10 meters per second square is used for gravitational force. So that is an example of theory which has been reviewed by several scientists and a conclusion has been made. Now there are different scientists. I'm going to make another video on all these great scientists of old that postulate theories that made life easy for us today. But to mention a few, we have scientists like Socrates, Plato, Aristotle. These were scientists that lived in the ancient Greek time, and they played a major role in physics. For example, Copernicus is a scientist that discovers that the earth rotates around the sun and not that the sun rotates around the earth. What a wonderful discovery, that the earth is the one that rotates around the sun and not the vice versa. Then we have another great scientist, Galileo. Galileo is one of the great scientists that discovered the sunspot and the planetary satellite, which perfected the telescope theory. The telescope that we use today was discovered by a man named Galileo. His full name is Galileo Galilei. Another very great scientist that the world cannot forget in a hurry is Isaac Newton. Isaac Newton was a very great scientist, and he was the one that discovered the 3 laws of motion. The 3 laws of motion that has been used widely in varieties of application in medicine, in engineering, in construction, and so many applications. 3 laws of motion was from Isaac Newton. Then the law of universal gravitation that I just mentioned the other time, the law of universal gravitation, was discovered by Isaac Newton. The invention of calculus. Calculus, a lot of students, mathematics students, engineering students, they don't like calculus. But Isaac Newton, he was the one that discovered calculus. And in our world today, calculus has several uses today. So I would not like this video to extend further. It's just an introduction class to physics. Like I said earlier, in the science class boot camp, we delve into mathematics, physics, and chemistry. We start from the basics to advanced level. We also share useful tips on materials that will be valuable for young people, like job opportunities, trainings, and scholarships. So if you are yet to subscribe to this channel, please do well to subscribe right now, especially if you are a student, you're a young person, you are in the college. You just have to subscribe to this channel right now, because a lot of valuable tips is being discussed. There's a lot to learn on this channel. So please do well to like this video, comment, and subscribe. I'll be waiting for your comment in the comment section. Please do well to hit the notification button so that you can see very useful videos that I post online. Thank you for your time today, and have a nice time. Bye bye.